Specifically called 1,000 minimal cost to merge stones. For this question, it gives us an n pairs of stones arranged in a row. And for each, the index I, the pile has a stone I stone. So for each move, we can merge exact k consecutive piles into one pile. And then the cost of this move is equal to the total number of stone in these k piles. Return the minimal cost of merge all piles of stone into one pile. If not possible, so we will talk about what is possible. Return -1. So let's look at the example 3 first. So we have 3, 5, 1, 2, 6. We have at the first step, we have 3 choices. We can either merge 3, 3, 5, 1, 5, 1, 2, or 1, 2, 6. And then it has three paths left, right? 3 paths left after the first merge. So the next merge will be the step 1, the step 2. Actually, the step 2, the cost, we'll see, no matter how we merge for the first step, the next step will be total sum of all this range, right? Because, for example, we have add 315, 351 into one part, that is 9, right? 9 to 6. Then we are also add 9 plus 2 plus 6. It's actually the summation of all the range, right? So for this step, the total cost is the sum of this range, right? From 0 to n-1. And for the first step, and the optimal solution is that we choose 5, 1, 2 as the first merge, because it only costs 8, right? So this is 17, right? So total minimal is 25. So intuitively, we're thinking about is that for this kind of approach, we're trying to choose the smallest cost for each time, right? So we're thinking maybe we can use greedy, but greedy, apparently this is not correct. We cannot use a greedy approach. For example, we have R6 for 6, right? If we use greedy, the first approach is if k equals 2, okay, k equals 2, then we will merge 4 and 4, so that 6, 4, 6, right? We have cost 8. Then choose this or this, you have same effect. We need a cost 14, right? So that's 14, 6, and then the next step is 20, right? So merge to one part, that is total cost will be 42, right? But for this kind of scenario, apparently, if we merge, for example, the first step as 6 plus this one as one part, right? So that is 10, 4, 6. And choose this one as one part, right? 10, 10. And then into 20, right? So this is 8. So this one will be this will be 10, right? 10. So the total cost will be 40. So total cost will be 40, right? So let's see. It's not necessary greedy is correct. So we skip the greedy approach for this kind of question, right? So what we're thinking about is that we can go to approach with the dynamic programming, that is DP IJ, means merge for the range IJ, include I and J, right? To the smallest number of counts, what is the minimal cost? Right, so DP IJ. So what we need is we want to return DP 0 and -1, right? So what is so we have two questions. First, for range IJ, how can it be merged to one part? So for example, IJ satisfy what kind of condition can merge to one part. The second question is that how can we use DPIG, the values we already calculate, right, to expand to those kind of range, have larger range, for example, to be 0 to n, right? So for example, we already have length equals to 1, right? Apparently length equals 1. We don't need to merge, right? That means the cost will be DPII will be 0, right? So we can set this as initial state. From those kind of state, we already know how can we expand, for example, how can we expand to length to equal to 2 until length equals to n, right? So what is DP transition functions, right? So let's talk about these two questions. So first question is how can range ij can be merged into one part? Well, see, if initially there is only one, right? It is already one part. Then let's look at the next part. We can add a k minus 1, right? So that means 1 can merge to one part, k can merge to one part, right? And what is the next? So that means this one we can merge to one part, and we can have another k minus 1, right? So that is 2k minus 1, right? But can be merged to one part. So in order the range I to j can be merged to one part. With the initial, those kind of formula will be the length of ij should be something like 1 plus, for example, L multiplied by k, right? Some kind of M multiplied by k. So that means the length minus 1 mod by k should equals to 0, should be divisible by k, right? So that is the first question. How can any range ij can be merged into one part? The second question is how can we do the DP transformations? We already have DP, let's say we want to say calculate DPIG, right? So the last state is that we want to merge the range I to j, right? The into the smallest account. Okay, so that's we can separate those kind of I to k, right? So let's say in the k plus 1 to j, right? The things that we want to see what is the previous state, right? So the previous state, we can always consider, for example, put the first one stone here, right? And so that means that is we separate it into I to k and k plus 1 to j, right? I to k and k plus 1 to j. That means we can always iterate. For example, we can merge, I will say merge this part into one part, right? And then the rest, no matter what kind of path number we want, right? So if for example k just be the same with I, right? That means this I is not merged with anyone. So this will cover all the cases that we can consider either this I is separate or merge this one into one pile, right? Or merge from I to I to I plus k, right? So this will be I plus 2k minus 1, right? So we want to see the previous state of the last merge. That is, we separate, we can consider, just imagine to separate this kind of range into this part. And the last state can be either this part, I to k, k plus 1 to j, or I plus 2k, right? We just iterate those kind of how many k's already being merged to this kind of the first with the first element, right? So that we are consider the divider. What is we separate with for example, we always put this one into one part, right? Because on the left, in the end, we always have one part, right? And for this part, we don't know how many parts. It may be but some number of parts from 1 to whatever you want, right? 1 to k minus 1, right? Kind of scenarios. So the thing is that we can always consider for this left part, right? So it merged, for example, from left one element in here. So we just consider the last step of the merge. So we iterate the divider, right? So every time we iterate the divider is increased by k plus 1, right? And so dpij will be minimal dpik, right? So L, let's say L, every time this L is from I, this divider is L, okay. And dp plus dp L plus 1 J, right? So that means that if in the end, for example, this is one part, right? This is one part. This is k minus 1 part, right? We can still merge the whole things into one part. That means we can if this one I and j, the length is k, the divisible by k minus 1, right? We can merge this part into one part. So we need to add this one to the total sum, right? Total sum of range I to j, right? So if we want to effectively calculate the sum in the range I to j, right? We should use a prefix sum to calculate the to write prefix sum first, so that we can every time from I to j we can calculate this part easily. So let's write code for this, and we can have, for example, private static final in f equals, because that means we want to find minimal, right? So we want to set the dp as maximal as initial value. So that means that let's have n equals stones dot length. So what we need is that we say in order this kind of n parts can merge to one part, right? So we need this kind of n minus 1 multiplied by k minus 1 should be equal to 0, right? So what we said, if this doesn't equal to 0, right, means we cannot merge into one part. We just return minus 1, right? So also we need a prefix sum equals new int n plus 1, right? So what we need to set for int I equals 1, I smaller than n plus 1. I plus plus, then prefix sum I equals prefix sum I minus 1 plus stones I minus 1. So we want to have dp, right? dp equals new 8 and n. So we'll say this kind of dp ij represent for the range I and j inclusive to merge to the smallest count, the minimal cost. It's not necessary that dpij can merge it to be one part, right? So what's the initial state, right? So we'll say for every int I equals to 0, I smaller than n, I plus plus, and dpri will be equals to 0, right? For every stone, we cannot merge it to self. And we can set the rest, for example, for int j equals to 0, right? J smaller than n, j plus plus, the rest to be infinity values, right? So we can have, right, dpij equals, so for example, I equals j, right? Then that is 0. Otherwise, we can have IF. Okay. So actually, so in this case, we know the length goes to 1, right? So for the dp, we need to iterate from the length 2, right? Or alternately, we can write something like if mass absolute I minus j smaller than k, right? Because that means from ij we don't have enough element, right? So in this case, we can iterate length equals k, right? Because for all of the lengths, um, all of the lengths, actually we say plus 1, right? This is length. All of the lengths smaller than k, right? They cannot merge, right? We can also write this. So then otherwise it will be infinity, right? So then we iterate the state. What we do is for int length equals to length smaller equal to n, right? Length plus plus. So what we do is that for int I equals to 0, I plus length smaller equal to n, right? I plus plus. So we'll say int j is I plus length minus 1, right? So we'll say we need to iterate. For example, we want to find the minimal cost to merge from I to J. We want to iterate the previous state. So we want to iterate the K as divider, right? The K as divider, that means this kind of stone can be merged with any numbers on with this K every time those kind of number of stones, right? So let's say the divider is L, okay. So because this already have K here, so that we have 4 int L equals I, L smaller than J, right? L, that's every time increased by k minus one, right? Because that means um we just say this kind of state, right? Just it will left one stone here, right? No matter what kind of a stone, it is stone I or any numbers, any k number, k minus one number of multiply and pass with to be one part, right? Um, then we'll say the dpij will be mass dot mean dpil and ij, okay, ij and dpi to l plus dpl plus one j, right? So the thing is that if this this ij, they have length to be if the length minus one to be the divisible by k minus one, right? Means this ij can be merged to one part. So we'll say if j minus I plus one minus one, right? So that we can get rid of this. So if this one is divisible by k plus one, right? That means we can do one more extra step to merge those kind of stones into one part. Then we'll have dpij is the plus equal to. So we'll see the last step is always adding every stones from I to j, right? Prefix sum j plus one minus prefix sum I, right? So in the end, what we need is return dp0 n minus one, right? So we'll say the time complexity, right? Let's talk about the time complexity. We iterate this kind of length and I, right? So it is actually two for loop. This is n square, right? And then we iterate the divider, right? For the divider, how many times we iterate is a multiplied by k, right? Or multiply divide by k minus one, right? Is actually the so we'll see the time complexity will be O n squared divided by k, right? So space we use a DP array that is n multiplied by n, right? And this is n for prefix sum, so it's n squared space complexity. Let's write a Python code for this as well. So we can have n equals length of stones. Okay. So what we do is that if n minus one mod k minus one done equal to 0, right? We just return minus one. Then we have prefix sum equals this one multiplied by n plus one. Okay. So we have the for I in range from 1 to n plus 1, right? I have prefix sum I equals prefix sum I minus 1 plus stones minus 1. Okay. Then we're going to have dp. Okay, dp equals so if it is if I equals j, right? Else that is float IF. Okay. For j in range n, right? So this one for I in range n. So this is the initial state. Then we are going to for length, right? For length, uh, in this length, we use length, okay, in range from 2 to n plus 1, okay. For I in range, uh, from 0 to n minus length plus 1, right? So I say j equals I plus the length minus 1, right? So we need to iterate the divider in range from I to j. Every time this kind of it will increase by k minus 1, right? Then we'll say dp I j equals mean dp I j and dp I l plus dp plus 1 in j, right? So let's say if this kind of in the end we can merge it into one part, right? If we need one more extra step and to merge that into one part equals 0. Then we have dp I j should plus equal to prefix sum j plus 1 minus prefix sum r, right? So in the end, we just need to return dp 0 and minus 1.